Okay, so chapter 14 is, in my opinion, the most important part of statistics because it goes over how to set up your studies and your samples and how to interpret them. Um, and if you don't do that right, then whatever data you collect is pretty meaningless. Um, in chapter 15, well, we start collecting data, and then we want to make some sense of it. So in section 15.1, we're going to talk about graphs and charts. And so some vocabulary that we use, that's one of the challenging things about learning math is you have to learn all this vocabulary. So data set is just a collection of data values. And capital N will represent the size of a data set. Data points, the individual data values in a data set. So the data point is the individual value. It's not necessarily physically a point. Discrete variable, we're going to talk about different types of variables. A discrete variable, the values of the variable can only change by a minimum increment, i.e. the values can be counted, right? So if you can count them, then it's discrete, right? And so is there any other kind of things? Well, there's also examples or test scores, age in years, number of children. You can count all those. And what other type of variables are there? There's a continuous variable, a variable that can take infinitely many values that can differ by arbitrarily small amounts, i.e. the values can be measured, right? So it's a continuous variable. So examples are the height, weight, money. These are all examples of continuous variable. Money is a little strange because it seems like the smallest that we can go down is down to the penny, but for practical purposes, we're going to look at money as being continuous. Example, Stat 101 test scores. The day after the midterm exam in his Stat 101 class, Dr. Blackbeard has posted the results online. The data set consists of n equals 75, so capital N is the number of data points. It's 75 data points. The number of students who took the test. Each data point listed in the second column is a score between 0 and 25. Dr. Blackbeard gives no partial credit. Notice that the numbers listed in the first column are not data points, and they are numerical IDs used as substitutes for names to protect the student's rights of privacy. So here's all the data, right? And so the data points are the scores. So these are the data points, right? And I don't know about you, but when I look at all this, nothing jumps out at me. It's very difficult to digest just all these raw data points, right? And so what we're going to learn in this section is how to process this information a little bit to make it more palatable, to make it easier to look for trends and understand things. And so one way of doing that is to organize your information into a frequency distribution. Like students everywhere, the students in the Stat 101 class have one question foremost on their mind when they look at the results. How did I do? Each student can answer this question directly from the table. It's the next question that is statistically much more interesting. How did the class as a whole do? To answer this last question, we will have to find a way to package the results into a compact, organized, and intelligible whole. The first step in summarizing the information in Table 14.1 is to organize the scores in a frequency table. In this table, the number below each score gives the frequency of the score. That is the number of students getting that particular score. So we have 75 students took the test. We have 75 scores, but they are not all different. What we would like to do is record how many students got what score. That's a frequency distribution. So here's the frequency table. Frequency table for the Stat 101 data set. So there was one person with a score of 1, people with a, one person with a score of 6, 2 people with a score of 7, 6 people with a score of 8, 10 people with a score of 9, and so on, right? And so this takes that whole table that we got earlier and makes it a little bit more manageable. And you can see some trends from there by looking at this table a lot more than you could from the raw data set. But as they say, a picture's worth 1,000 words. So we can do even better. Figure 14.1, next slide, shows the same information in a much more visual way called the bar graph, with the test scores listed in increasing order on a horizontal axis and the frequency of each order on a horizontal axis. And the frequency, with the test scores listed in increasing order on a horizontal axis and the frequency of each test score displayed by its height of the column above that test score. Notice that in the bar graph, even the test score with the frequency of 0 show up there, simply as no column above these scores. And so our possible scores on this test are any number between 0 and 25. So all the possible scores are down here, 0, 1, 2, 3. And whatever frequency you got, well, you go all the way up to that to make your bar, all right? So there was one person, so you go up to 1 for that. There was one person with a 6, so you go up to that. There was 2 people with a 7, so you go up to there. 6 people with an 8, so you go all the way up to 8. And there you go. This is the frequency over here on the vertical axis, and this is the score over here. And you can see that in this class, most of the people were around here, right? And you have a couple of outliers. You have this 1 here, and you have this 24 out here. These are called outliers. These are far removed from everybody else. Bar graphs are easy to read, and they are a nice way to represent a good general picture of the data. With a bar graph, for example, it's easy to detect outliers, extreme data points that do not fit into the overall pattern of the data. In this example, there are 2 obvious outliers, the score of 24, way above the rest of the class, and the score of 1, way behind the pack. Sometimes it is more convenient to express the bar graph in terms of relative frequencies, that is, frequencies given in terms of percentages of the total population. Figure 14.2 shows a relative frequency bar graph for the STAT 101 data set. Notice that we indicated on the graph that we are dealing with percentages rather than the total counts, and that the size of the data set is n equals 75. So if we go back to our frequency distribution, there are 75 students, right? And so then one person got a score of 1. So the relative frequency would be to take, there's 1 out of 75, right? And you can write that as a percent, 1.3%. If you round that to the nearest tenth of a percent. One person got a 6, so that would also be 1.3%. 2 people got a 7, so 2 out of 75 got a 7. So that would be 2.7%. And you do that for every possible score. And so the height of your bar is no longer the number of people. The height of your bar is the percent. And you get a relative frequency distribution. Right? And so that's what this is. On the left is the percent of students receiving the score. So 1, there is 1.3%. And then 7, there was 2.6%, and so on. Right? So here you have how many students how many scores you have, 75, and over here, this is the percent of students. So this is called a relative frequency bar graph. Okay. Bar graph versus pictogram. Frequency charts that use icons or pictures instead of bars to show the frequencies are commonly referred to as pictograms. The point of a pictogram is that a graph is often used not only to inform but also to impress and persuade, and in such cases, a well-chosen icon or picture can be a more effective tool than just a bar. So here's the same bar graph, but he put pictures in here instead. On the left is still the frequency. On the horizontal axis is still the score, but notice he's got a little sad face because he only got a 1. And then these get less and less sad. This guy here at a 10's, and 11 starts getting a little happy, 12 a little happier, and number 24 over here, he's real happy. So adding pictures like this helps persuade people in one way or another. Okay. Selling the XYZ Corporation. Now again, as consumers of information, and that is what you are, whether you want to be or not, you're going to be presented with pictures that are going to that are designed to influence you, and you need to be able to look at those pictures and process them. So this figure is a pictogram showing the growth in yearly sales of the XYZ Corporation between 2001 and 2006. It's a good picture to show at a shareholders meeting, but the picture is actually quite misleading, right? So by looking at this, it looks like there is a big rise from 2001 to 2006, right? You're going from 50 to 80 to 78, something like that, 77, 77, 78, and it makes it look like it's a big jump, right? And the reason why it makes it look like it's a big jump is because they chose to start right here at 50 instead of 0. And that then was then going to make this rise seem bigger than it actually is. This figure shows a pictogram for exactly the same data with a much more accurate picture of how well the XYZ Corporation had been doing. Now the rise doesn't seem so dramatic. So just like everything else, people will abuse, and sometimes intentionally, sometimes on accident, information. You have to be able to process it and make informed decisions. The difference between the two pictograms can be attributed to a couple of standard tricks of the trade. 1. Stretching the scale of the vertical axes, and 2. Cheating on the choice of the starting value on the vertical axes. As an educated consumer, you should always be on the lookout for these tricks. In graphical descriptions of data, a fine line separates objectivity from propaganda. So, exercises 1 through 4 refer to the data set shown in Table 15.2. The table shows the scores on a Chem 103 exam consisting of 10 questions worth 10 points each, right? And so we're only keeping track of the scores, right? And so what we want to do in problem number 2 is draw a line graph for the data in Table 15.12. And so all a line graph is instead of making a bar, we put a dot at the height of each, representing each frequency, and then we connect the dots, right? So we're going to start with a frequency distribution. Let's come back over here to look at the standard. We have the score, and then we have the frequency, right? So over here we have the score, and over here we have the frequency. Okay, so let's look for the lowest score. We got a 10, and since each problem is worth 10, there's only going to be, that's the lowest score. All right, so we have 110, and the score of 10 only had a frequency of 1. Next lowest score, just to try and stay in order, looking for something lower than 10. I'm seeing 40. And there was only one of those as well. And then I saw some 50s. 1, 2, 3. There was 3 of them. And then definitely saw some 60s. 1, 2, 3, 4, 5, 6, 7. 7 60s. And then 70s. 1, 2, 3, 4, 5, 6. Okay. And then 80. And then we have 1, 2, 3, 4. And then 100. And there only one of those. And it looks like I missed an 80. So 1, 2, 3, 4, 5. Ooh, and I also missed 100. So there was 5 80s and 200s. And so for a bar graph over here, start with 0 and then 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then for the frequency, we're going from 0 to 7. 1, 2, 3, 4, 5, 6, 7. So instead of drawing a bar to only 1 right there, right? It should be the 1. Now for a line graph, which is what we're being asked to do, draw a line graph. For 10, there's only 1, so we just put a dot there. For 40, there is 1, so we put another line there. And then for 50, we put a dot at 3. 1, 2, 3. And then for 60, there's 7, all the way up to the top. And then for 70, there's 6, 1 down from the top. For 80, there's 5, 1 down from there. And for there was no 90, and for 100, there was 2. And then we just connect the dots with lines. And there you go. That's a line graph. Categorical variables and pie charts, right? So another common chart that you will see when people want to display their information is with a pie chart instead of a histogram. Now, in a circle, there is a total of 360 degrees. So if you want to represent a percent of the population, so 25%, then you will use 25% of those 360 degrees. And again, that's just the basic percent form problem, 0.25 times 360, and then 0.25 times 360 is 90. So you will use a central angle of 90 degrees. And I don't expect you to go out buy a protractor to measure the angles, just, give a rough estimate for me. There are computer programs that can do this for you. But for me, you're just going to ballpark it. What a 90-degree angle, what a 180-degree angle. Then you just ballpark it. So variables can describe non-numerical characteristics of a population: gender, ethnicity, hair color, feelings, etc. These are called categorical or qualitative variables. So things that cannot be described with a number are qualitative. Things that can be described with a number are called quantitative. The figures below display categorical data in both bar and a pie chart. So in uh, a bar chart, your bars don't have to represent numbers. They can represent categories, right? So this is the majors of students at a university, right? So agriculture, you have 2,400. Business, you have 1,250. Education, you have 2,840. Humanities, you have 3,350. Science, you have 4,870. And other, the famous other, you have 290. And so another way to display that information is, instead of a bar graph, to use a pie chart, right? And so a pie chart, so if you look at the total, your total is the 2,400 plus the 1,250 plus the 28,040, I'm sorry, 2,840, 3,350, 4,870, and the 290. And there's a total of 15,000 students, right? So if there's a total of 15,000 students, then the percent of agriculture majors is 2,400 divided by the 15,000. The 2,400 divided by the 15,000 is 16%. Now, so then to put this on the pie chart, one complete revolution is 360 degrees. So we take the 16% and we multiply it by 360 to see how many degrees my slice of agriculture should be. And so then 0.16 times 360, 57.6. And since we're not going to be measuring it that quick, we're looking at about a 58-degree angle. So we're looking at about a 58-degree angle. So there's your agriculture. So what that means is you want this angle right here to be 58 degrees. You can do the same thing for every other category. For business, it's 1,250 divided by the 15,000. And then you multiply that times the 360, and that gives you a 30-degree angle. So for business, this angle right here needs to be approximately a 30-degree angle, right? So it doesn't really matter where you start. So you could have started your first wedge right here, and if you're doing agriculture, you rotate it 58 degrees to get your second wedge. Sorry, to get the other side of that wedge. And then if you're doing business, then this right here has to be 30 degrees. Education is 2,840 divided by 15,000. And then you multiply that by 360 and you get a 68.16 degree angle. So you can see that the education wedge is bigger than the agriculture wedge, and really it should measure 68 degrees. For the humanities, 3,350 divided by 15,000 times the 360. You need an 80-degree wedge right here, a big humanities, so that wedge is bigger than the education. And the science is going to be the 4870 divided by the 15,000 times the 360. That's the biggest one, and you're going to get a 116 degree wedge, 117, sorry. And we did round these all off to the whole number units. But if you add the 58 with the 30 and with the 68 and with the 80 and with the 117, you get 353 degrees. One complete revolution is 360 degrees. So that means this wedge right here has to be the other 7 degrees. Or you could calculate it directly, 290 divided by 1,500 times the 360. Sorry, divided by 15. So 290 divided by 15,000. I said 1,500 times 360. And yep, it tells me 6.96 rounded to the nearest whole. That should be a 7-degree wedge. So that's how you figure that out. Example, construct a pie chart. The table shows the breakdown of how a typical full-time college student spends a typical weekday. Data includes individuals aged 15 to 49 who were enrolled full-time at a college or university. The data are averages for 2006 to 2011. Okay. So there are 24 hours in each day. And so then if your typical student sleeps 8.4 hours a day, then the percent of the time they spend sleeping is 8.4 divided by 24. So 8.4 divided by 24 is 35%. So they spent 35% of a day sleeping. So the size of the wedge should then be 0.35 times 360. 126 degrees is the wedge for sleeping. Leisure sports, and they spend 3.6 out of 24. So 3.6 out of 24. They spend 15% of their time on leisure and sports, which then you do 0.15 times 360. 54 degrees should be the size of your wedge for sleep. Work is 3 out of 24. And they only spend 12.5% of their time working. So the size of the wedge that corresponds to work should be 0.125 times 360. 45 degrees. Education, what they're there for. 3.4 out of 24 is 14.2%. Times 360 should be a 51 degrees. a 15.1 degrees wedge. Eating and drinking, 1.1 out of 24, which is a 4.6% of the time. And so then times 360, 16.5 degrees. So we'll go 16.6, I'm sorry, 17 degrees. Grooming, 8/10 divided by 24. And that will be 3.3%. And then you take your 0.033 and multiply by 360 degrees. These should all have degrees on them. It should be a 12-degree wedge. Travel, 1.5 out of 24. 6.3%, which implies 0.063 times 360 degrees, 23 degrees, a wedge that's 23 degrees. And then the other is 2.2. We don't really need to do the other because once we find all the other wedges, then we're done, right? And so you draw a circle. And you don't have to go straight down, but I will to try and make my life easier. So my first wedge is for sleep, and it's 126 degrees. 90 degrees would be straight across, so we need to go another almost 40 degrees. And there you go. And that's sleep. Okay, then leisure and sports was 54 degrees. So you're going to start here now and rotate. You're going to ballpark it to what 54 degrees looks like. If you had a protractor, that would make it easier. But then that is going to be leisure and sports. Work. Work was only 3 out of 24, which is a 45-degree angle. And then education was 51 degrees, a little bit more than that. Ed. And then eat, drink was 17 degrees. And then grooming was 12 degrees. And that looks bigger than the other one. So again, there we go. Grooming. Travel was 23 degrees. And so on. And that's how you make a pie chart. Okay. So let's move on to class intervals and frequency. Class intervals are a way to aggregate data into ranges or intervals. It is an easier way to draw conclusions about large amounts of data. So the figure below displays the data in intervals, right? So rather than just using one bar for one score, we could use a bar for a range of scores, right? And so that's what's going on here. So here we had 1,494,531 data points, and we our values ranged from 200 all the way to 750, and so if we had a different bar for every single score, um, that would get convoluted. So instead, we decide on a range, right? So the bar on the left goes from 200 to 249. The next one, any are values from 250 to 299. Notice that they're all about the same width. From 300 to 349, from 350 to 399. And notice that your scale here is 50,000. So this right here looks like about a fifth of that. So that might be like 10,000. And this one would be like 12,000. This one here would be about 60,000 or 57,000, somewhere around there. But it's just to give you a general idea of how your data is spread out. With so many numbers, this gives you a good indication still of what's going on. Still that a lot of your data is here in the middle, and it's nice and symmetric, right? Things to be learned from that. Okay. Example, construct a frequency table using class intervals. Recall the midterm grades for Professor Blackbeard's Stat 101 midterm. Suppose his grading scale is 18 to 25 is A, 14 to 17 is a B, 11 to 13 is a C, and 9 to 10 is a D, and 0 to 8 is an F. Recognize that not all of them have the same width, right? Organize the frequency table using the class intervals above, right? And so now, instead of a score, we want to use these categories. And the categories are well, let me start there. Let's start F, D, A, sorry, F, D, C, B, and A, right? And so everything between 0 and 8 is an F. And so that includes all of these right here. And so we have 4 Fs. Everything between 9 and 10 is a D. So 9 and 10 are these right here. We have 10 here and 16 here. So we have 26 Ds. And everything between 11 and 13 is a C. So 11, 12, and 13, that's these three right here. And we have 13 and 9 is 22, and 8 is 30. So we have 30 Cs. Okay, and then everything from 14 to 17 is a B. So 14 to 17 would include all of these. And so that's 5, 7, 8. And then there is only one A, right? So everything 18 to 25 is an A, but there's only one. And so there we go. Then what we could do is we could take that and make a bar graph for each category, right? So looks like we have biggest one is 30. So we got to get all the way up to 30. So we can go up by 5, 5, 10, 15, 20, 25, 30. And so for F's, we have 4. So we have a bar here that goes up here, doesn't get to 5 because there's only 4 of them, and that would be the F bar. For D's, we have 26. So 5, 10, 15, 20, 25, and then a little bit more, 26. And that would be the D bar. C's, we have 30. So we start here, go all the way up to the top here, come across, and that would be the C bar. And then B, we have 8. So here, before we get to the 10, we stop, and that would be the B bar. And then there's only 1, so we need a 1/5 of the way up for the A's. And so what we have here is a bar graph for the grade distribution. Okay. Continuous variables and histograms. When numerical data is continuous and in small increments with no gaps, the histograms, similar to a bar graph, are a better way to display the data. Histograms display the data in intervals with no spaces in between the bars, as in the figure below. And so here we have the salaries and percent of people. We have 3,258 people that we're looking at, and now we're looking at the salaries in thousands. And because we have so many, we group we group them in intervals, and because it's a continuous, we have no gaps, right? This is continuous data. So the first interval goes from 40, and the plus, I believe, indicates that we're including the 45, if I'm not mistaken. So anybody with a salary of 45,000 would be in this first group. And this is telling us that we have about 7% The next group goes from 45 to 50. If you're in 50, you're in this group. If you're exactly 50, you're in this group. And so that gives us that we have about 14%, and so on. The table gives the home to school distances D measured to the closest 1/2 of a mile for each kindergarten student at Cleansburg Elementary. Okay. And so since this is continuous, distance is continuous, what we're going to want to do is make a histogram, not a bar graph. Histogram are bars touch, right? And so our distances vary from a low of 1.50 to a high of 6. Okay, so we want to organize this in a histogram, not a bar graph, because the distance is continuous. Okay, so notice that we go from a low of 0 to a high of 8.5. And so then what I'm going to do is I'm going to go up by 1.5 so I don't have that many bars, right? And so we're going to go from 0 to 1.5. and we're going to include the 1.5 in the first bar. And then from 1.5, we add 1.5, and then we'll go to 3, and we're going to include the 3 in the second bar. And then from 3, we'll go to 4.5, which is going up by 1.5. And then from 4.5, we'll go to 6. And then from 6, we'll go to 7.5. And then from 7.5, we'll go to 9. Okay, so including the right endpoint, right? So that means then that for for 0 to 1.5, we're going to include 0, 0.5, 1, and 1.5. So we have 4 zeros, 1, 2, 3, 4 zeros, and then we have 4.5s. 1, 2, 3, 4, and so that's 8. And then we have ones. 1, 2, 3. We have 3 ones, so that's 11. And then 1.5s. We have 7 1.5s, so we have 18. Since we have 18, and I'm only going to go up, I'm going to go up by 5s. 5, 10, 15, and then 20. And so from 0 to 1.5, we have 18. You can just count all those, right? And now from 1.5 to 3, not including the 1.5 because the 1.5 was in the first bar. So then we have 2, 2.5, or 3. So we have 1, 2, 3, 4, 5, 6, 6. And then from 3 to 4.5, not including the 3, so that'd be 3.5, 4, and 4.5. We don't have anybody. And then from 4.5 to 6, not including the 4.5, but including the 6, we have 1, 2. We only have 2. And then from 6 to 7.5, we don't have anybody. And then from 7.5 to 8.5, we only have 1. And there we go. The space here, there's not a space. It's just that there's nobody there. And there's our histogram. And so your homework for this section is 1 through 21 odd. Okay, this will also be due next Wednesday, and we're done.